secondary. So here we are going to discuss lead storage. Okay. Please open the book and see in your book the diagram you see. Okay. This is the case. We mean by hard plastic, or sometimes we call it gata patta. Okay. This is the metal rod. This is the cathode. And this is anode. Okay. Now this is the electrolyte. This electrolyte is made of sulfuric acid, 38% by mass. Okay. Specific gravity or density is 1 point. I'll write down. Too small is the note. Specific gravity is 1.30 grams per ml. Okay. So here you are having system battery you have seen in your car. Okay. Now both Anode and cathode. Cathodes are made of lead grid. Grid means strong metal bar. It's called grid. Okay. So I'll write now here anode sponge lead. Spongy lead. Spongy lead supported on lead grid. Cathode PbO2, lead dioxide, supported on lead grid. Electrolyte H2SO4, I've already written inside 38% by mass. Specifically already I have written. Okay, please try to draw from your book. So now I'm going to write the reaction. You'll first try to understand, then only you'll write. Otherwise, you don't write. Because in your book they have given so shortcut, so it is difficult for you to understand. Clear? Okay. Now reaction at okay. So I'll write it here. Then this will be the place where I write the pair. It's difficult for me to write below because I developed that way. But still, I'll do it for you. So it is reaction at N. See, you know what is this going to happen? Lead. Because it is spongy lead. So what is lead grid? It is a hardly beaten lead plate. And on the top of that lead plate, soft lead is being added. Soft lead. This is called spongy lead. So see here, what is going to happen? Lead is going to lose electron. Okay. Now dear, see here, what is the electrolyte? Electrolyte is sulfuric acid. Sulfuric acid dissociates to give you H plus and SO4 2 minus. Please remember, most of the lead salts are insoluble. They are not soluble. What is going to happen now here? Pb2 plus aqueous will combine with lead sulfide aqueous to give you lead sulfate, which is insoluble. Sometimes you will find if your father or your brother uh, opens the car battery, and from there we want to drop solution, falls outside. After some time we'll find it has become a white powder. This is this. Okay, so I'll write here now PBS SO4 2 minus aqueous give you lead sulfate solid. So this lead sulfate will now deposit on the surface. So I'll write now here. PBS SO4 2 minus aqueous, it will give you PB2 plus, don't write. Okay, now reaction at cathode. Reaction at cathode. See here, PbO2. It gives you, see here, oxidation state is +4. Please remember. So it will give you Pb4 plus. Okay, plus 2O2 minus O2 na. So 2O2 minus. See, Pb4 plus will take 2 electron to become Pb2 plus. Now see, that is, it is acting as a cathode, is taking electron. Now, again we know Pb2 plus combines with sulfate to become Pb sulfate. What will happen to O2 minus? 2O2 minus will combine with 4H plus. So you can ask me where from 4H plus has come. Here sulfuric acid H2SO4, each has 2H plus. See, one sulfate is here. From here I get 2H plus. Another sulfate is here. I get another 2H plus. So total become 4H plus. So it will give you what? 2H2. So it is a long future. Okay. Now I'll add. See here. This. Okay. This. So ultimately, total I will not write it here because it will be difficult for you to see. Yeah. I'm going to write total here. So reaction at. So now you'll understand how in your book they have made it so shortcut. 4H plus. See here, PbO2, 4H plus, SO4 2 minus, SO4 2 minus, aqueous plus 2 electron. Okay. So I'll make equal sign here. No place to write. So what should I write? Okay. See, PbSO4. See, all the cancel. This and these are not cancelled. These two plus 2. Now let me get. Okay. Now what should I write here? You know very well. I should write here now. Overall reaction. So it is PVS, PbO2s, 4H plus 2SO4, 2 minus. See, if I combine both of them, it is 2 molecules of sulfuric acid. It will give you this plus this. And electron, this electron and that electron get cancelled. Okay, I can write here. So it will be 2 PbSO4s 2H. So this is the equation. The description, please read from the copy that I have sent, or you can read from the book. The description of the cell, I have written, whatever I have written in my note, I have written it from your book. So this one you can write separately, and this equation will be here. Okay, so please write this equation here, because if I write anything, you will not be able to see. So this is the final equation of the cell.
Excuse me, sir.
Yes.
So in overall reaction in book, there is no 4 plus H. You will be wrong, or you will be. The book is wrong, sir. The 4H plus is not there in overall reaction.
In overall reaction, it is not there.
It's not
Then
there in
what
book.
what to happen with the oxygen? You tell me. Can you balance it? See, can you balance this equation? See, how will you balance this oxygen? This oxygen you cannot balance. So that is wrong in your book. This oxygen has to be balanced, huh? Okay, I'll show you now. See what mistake your book has done. See here. See, lead sulfate. Lead sulfate is there. All right. One lead is here. One lead is here. Okay. Sulfate is here. All right. What about this O2? In your book, O2 is given or not? PbO2. Check in the book.
Yes, sir.
Then where is the O2 here? Where is the oxygen? It has to be balanced or not?
Right, sir.
Huh? So you do the correction in your book also. Write 4H plus and write 2H2O. So that is wrong in your book. Many things are written shortcut in your book. That is not wise. Textbook should be always correct. Otherwise, you will learn wrong thing. Finish writing.
Yes, sir.
No, sir.
Okay. Okay. Right. Did you write these two separately? In your textbook, they should have written this equation separately in a box so that students could understand it. Otherwise, you have simply have to by heart. Chemical equations are not supposed to be by hearted.
Done, sir.
Okay, now see here. These are negative electrons. Negative, positive, negative, positive, negative, positive. So depending upon the vehicle that you are using in your car, you will find these type of three plates are there. But if you go for a heavy vehicle like bus or truck, or even if you go for inverter, you will find in this case 4 to 6 battery. Each of them, this is battery. This is one battery, this is one battery, this is another one. So it contains 4 to 6 batteries. Okay. So on the basis of that, you will find you will have by 6 volt, 12 volt, this type of batteries are available. Now, this reaction which I have written, in this reaction, electricity is being produced. That is, in this case, when your automobile is switched off, you have not started your engine. In this time, you can switch on the light, you can switch on your music system, you can press horn. All this process will occur by the consumption of electricity from the battery. So this is the equation of discharge. Okay, this process is called discharge. This is the equation of discharge. But once you start the vehicle, okay, in that case, what will happen? From your generator, direct current will pass in the reverse direction of your battery, and the battery will get automatically charged. So you'll find during lockdown, many of us, we are not taking out our car. And if you keep it for say 2 weeks, 3 weeks, 4 weeks like that, in that case, you'll find your battery will not function. And if your battery is old, you will not go to start your engine. Why? Because this electrode, see here, these are the electrode. Anode undergoes complete corrosion. If anode undergoes complete corrosion, then one of the electrode is missing. The battery is not going to function. So even in the process of your not using the car, maybe after a gap of 2-3 days, you are supposed to ignite the, suppose you will start the car, keep it in rest position and keep it for 15, 20, or even for, if the battery is old, keep it for half an hour. So your battery will be charged again and it will be almost fresh. Now, when you go for charging, I told you, in that case, the electrochemical cell behave like an electrolytic cell. And in that case, what happens? The cathode becomes anode. So, moment you go for discharge, sorry, for discharging, these are the things. And when you charge it, when your engine is on, in that case, you'll find this will be just opposite. This will be just opposite. Then in that case, this cell is going to behave like an electrochemical, sorry, electrolytic cell. All right. So I'll write down the equation and that will be the just reverse. The reverse reaction is not being given in your book. So I'll write here discharge rate. And this is for charging. Charging. So for your information, when automobile engine is off, this reaction produces electricity. Charging reaction, when automobile engine is on. So in electrolytic cell, we have first write the reaction of cathode and followed by anode. And as the cell become reverse, the equation also will be reversed. This right hand side will become left hand side and left hand side will go to right hand side. So I'll write like this now. Reaction at cathode. What is written there, cathode? 2 PbSO4 solid plus 2H2O. It will give you PbO2s 4H plus aqueous 2 sulfate aqueous. I'm writing here 2 electron, no space to write. Okay, and reaction at anode. At anode. So it will be PbSO4s plus 2 electron will give you PbS plus SO4 2 minus aqueous. Add it. Overall reaction. Okay. So this one you write on this side and this one you write on the right hand side. So it will be 2 PbSO4s plus 2H2O will give you PbS PbO2s 4H plus aqueous plus 2SO4 2 minus aqueous. Take care for your entrance exam. how to write this cell cell, how to represent this cell, because every time you're gonna draw it. Okay, so representation of lead storage cell. So we are supposed to write anode on the left and cathode on the right. So now we know this is the anode. Then what you have here? Lead sulfate. Because in cell, so you are supposed to write the electrolyte also. Then what you have here? H2SO4, 38%. Then PbO2, supported on what? Supported on lead. This is the representation of lead storage cell. Hello, Dan.
Yes, sir.
Yes, sir.
Then why you, after writing, then why you remain quiet? Could I have to ask you after every 5 minutes? Huh? See, we have found that time to time in your car battery, distilled water has to be added. Why? Because when the car is being used, then because of the engine, the inside is being heated up, so the evaporation of water takes place from the battery, by which what happens, the density of the sulfuric acid increases. But it is always being kept at 38% because you do not know what percent is added, but you know what is the specific gravity. Specific gravity should be 1.30. So if you go to a garage, you'll find they will put density meter inside that liquid, and if it is density is all right, otherwise what they'll do, they will, if the density is higher than 1.30, to that they will add distilled water. And if the density is less, that is your H2SO4 has decomposed, in that case they will add sulfuric acid. This is the reason for which the distilled water is being added in your automobile battery. Now we'll go for, in your book they have given nickel cadmium cell. Nickel cadmium cell. These are the cells which are being used for our mobile batteries. But in this Android era, we require a cell which can get immediately charged and can be used for a long time. So these days, instead of using nickel cadmium cell, we are using lithium cadmium cell. So anyway, it is beyond our discussion, so I will not discuss. Okay, in nickel cadmium cell, what is being done? These cells are costly, no doubt, but these cells are very compact, light, and produces electricity for longer time. And it is easy to charge. So in this case, what is the anode? Anode is nickel and cathode is anode is cadmium. Anode is cadmium and cathode is nickel dioxide. Electrolyte use is potassium hydroxide. Okay. Now we'll write here now. Reaction at anode. Okay. So again, I'll write it separately. Reaction at anode. What happens? Cadmium loses 2 electrons and it gives you this. But we have seen in the mercury cell also, as hydroxide is there, so the hydroxide immediately will combine to give you cadmium hydroxide. Cadmium hydroxide is not stable, so it will give you cadmium oxide and H2. Let me add it. So you will get now here cadmium S 2OH aqueous will give you cadmium oxide and H2. So I'll write now here cadmium 2OH aqueous will give you cadmium oxide plus H2O plus 2. Then reaction at okay. So here I'm writing reaction at okay. This is my rough. What is this? See here it is plus 4. Okay. So now okay. All right. It will be see this is the cathode taking electron. Okay. Now nickel 2 plus will take 2OH minus to give you nickel hydroxide is stable. Okay. Now you have O2 minus. 2 O2 minus plus 2 H2O will give you 4 OH minus. Okay. So what will be the total? Total I'm writing here because if I bend it, I develop P. So I'm writing here now. NiO2s. See 2H minus and 2H 4H na 2H minus and 2H minus 4 from it get cancelled to get 2H minus. So I'll write here now 2H2O 2 electron will give you nickel OH twice plus 2H minus. So overall reaction, this and this gets cancelled, this and this get cancelled. So you get here now cadmium S, NiO2s, 2H2O. It will give you cadmium oxide S, nickel hydroxide is also S, plus 1 H2O and 1 H2 get cancelled. So this is the one. So it will be here I write 2H. So this will be cancelled. Sorry. So this is for when you are using the mobile. And what will be the overall reaction? Now I told you in that case you need not write so many things. This will come to the left hand side and this will go to the right hand side when you are charging your mobile.
Done, sir.
Done, sir.
Okay. Do you know the meaning of fuel? F-U-E-L, fuel. What is the meaning of fuel? Have you heard the name of fuel earlier?
Yes, sir.
What is a fuel? So many of you are there. Why others are keeping quiet?
Petrol, diesel, coal.
No, these are the examples. What is the definition of fuel?
A substance that give energy by heating, by burning.
Yes, exactly. A substance which produces energy on combustion. Okay. So when we say combustion means what? The substance reacts with the oxygen of the air. Any substance which reacts with oxygen, that means it undergoes oxidation. Okay. Then it produces heat. And this heat is being converted into energy. Heat is an energy only. So that being utilized for different purposes. So now, suppose in your house we are using LPG. Some cases you may have to use kerosene as a fuel. In many villages, in a township, all may not have may not use what I should say this LPG as a fuel. So those people, they are using kerosene, or in Shillong you'll find they are using charcoal. If you go to plains, they are using coal.
মাঝে মাঝে তো শুরু করে
Hello. So now that is, you can use solid fuel in the form of coal, charcoal, or if you go to villages, people are using firewood. So they are using solid fuel. We are using kerosene as a liquid fuel in domestic purposes. But when you go for machinery, we are using petrol, diesel. Okay. In your laboratory, you are using spirit lamp. In spirit lamp, we are burning alcohol, ethanol. Or you can use petrol gas or LPG gas. In all these places, you find if they come in contact or they are being burned in presence of oxygen. So they produce energy. So now, that is, it is an oxidation reaction. I can say it is a redox. By the redox reaction only, the heat energy is being produced. So after going to the electrochemical cell, we found all these spontaneous redox reaction are being used. The energy is being used in the form of electricity. Why? Because in the process of redox reaction, the flow of electron takes place. Okay. Some substances undergo oxidation, electrons are lost, and this electron goes to some other place. So it is getting reduced. So where from we are harnessing this electron, because electron cannot be consumed. Electron you can never kill, you can never consume. So when the movement of the electron takes place, we utilize it. After utilization, electron again goes back. Okay, say you are getting municipal water. The water you are using it, maybe for drinking, washing, and all these things. But mind it, this water does not disappear from earth. Okay. If you consume this water comes out through our sweat, or maybe in the form of urine. Okay. Or ultimately again it goes back to the nature. So similarly, the electron which moves from one source to the sink. Source means anode. Sink means cathode. In this way, the electrons are being used or harnessed for generation of electricity. Take the example of coal or carbon. You have burned it. It has given you carbon dioxide and heat is being produced. You know it is around 394.5 kilojoule of heat is being produced. See here, oxidation state of carbon is 0, oxygen is 0. But here what happens? Carbon is +4 and oxygen is -2. That is, each carbon has lost 4 electrons and each oxygen has taken 2 electrons. So when this movement of the electron takes place here, this electron, if we allow to pass through a bulb, okay, the bulb will glow as per our electrochemical cell theory. And exactly the people have done it. Okay. And they have produced a special type of cell. These cells are called fuel cells. In fuel cells, what is being done? The oxidation or combustion of the fuel, the energy produced by the combustion of fuel is being converted into electricity. That is, these cells are called fuel cells. See, this is the beauty of chemistry. Okay. Fuel cells. Galvanic cells that are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy are called fuel cells. Example only I can give you. This is the most common one: hydrogen, oxygen, fuel cell.
Done, sir.
Okay, so now I'll show you. So I'll now go for hydrogen oxygen fuel cell. This is cathode. What is this? Perforated. Graphite electrode. This is anode. This is also perforated graphite electrode. So through that we send dry and pure hydrogen gas. And through this we send dry and pure oxygen gas. And this is the electrolyte. This electrolyte can be either potassium hydroxide or sodium hydroxide. It is COH electro. The electrodes contain catalysts such as platinum, silver, cobalt monoxide, cobalt oxide. Okay, etc. So I'll explain. Reaction. Reaction at anode. See here. Hydrogen gas will act as an anode. So each hydrogen will give 2 electrons. Okay. Reaction at cathode O2G. See, oxygen has 6 electrons. It takes 2 electrons to become O2 minus because it has taken 2 electrons. For each oxygen you require 2 electrons, but you are having 2 oxygen atoms. So I'll write now here 4 electrons. Then here I'll write. Oh, wait. Don't write anything. Eh? Okay, I'll do it separate. reaction at just try to get above. At H2 G 2H plus aqueous and 2 electrons. That is, hydrogen has come when the moment after that H plus goes inside. What you have here? Hydroxide or no? What should I write now here? Immediately 2H plus aqueous will combine with 2OH minus aqueous to give you 2H2O. I'll write now this. So it will be, see this and this will cancel. It will be H2G plus 2 electron, sorry, 2OH minus aqueous. It will give you 2H2O plus 2 electron. Okay, so I'll write now here. H2G 2OH minus, it will be 2H2O plus. Now I'll write reaction at this. You'll write separately. Reaction at what you have here? O2. So O2 will give what? 4 electron to get itself converted into 2 O2 minus. Now O2 minus combines with H2O to give us 2OH minus. How many are there? 2. So if I write 2, then I have to write here 2. Then I have to write here 2. Aqueous. 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 It will be O2. Sorry, I have to write here G. 2H2O, 4 electron gives me 4 OH plus. Okay, so I'll write now. O2G 2H2O. Did I make any mistake? No. Correct. Plus 4 electron gives me 4 OH minus. See here. Place low, all of you. Here you have 2 electron and here you have 4 electron. What should I do? I have to multiply them. Excuse me. Hello. Good evening. হ্যাঁ হ্যাঁ মনে আছে হ্যাঁ খুব ভালো, very good. I'm so happy. তোমার বাবা তো ওদের নিপোতে চাকরি করেন না? আচ্ছা, ভেরি গুড, ভেরি গুড। আরে থ্যাংক ইউর কোনো দরকার নাই তো, কষ্ট তো। ওভারঅল রিঅ্যাকশন 2H2. 2H2G, 1 only. Okay, now see here. 2 into 2, 4H get cancelled. Okay, 2 into 2, 4H2O, 2H2. So water will come in this. Okay, see, it is the same ratio by which hydrogen and oxygen undergoes combustion to produce water. But the beauty is that in that process, only heat is generated, but here people have produced electricity. Okay, so this one you write separately, and you finish it. Then I have to tell something more.
Done, sir.
Okay, see, whenever we burn any fuel, 50% or more than 50% of the energy is being wasted because heat is being radiated. See, in your house, when you are cooking or using LPG stove, okay, you'll find only upper part of the flame you can use it. Upper part of the flame. Okay. So if this is the flame, okay, only this part you are using. That is, if you consider it to be a 360-degree, because heat, though the flame is not coming from this side, heat is being produced. Only a part of it, maybe 20 or little more than 20% of the heat is being used. Rest of the heats are being wasted. But in fuel cell, all the electron that is involved in this redox process, you are harnessing to produce electricity. So theoretically, fuel cell energy can be utilized 100%. 100%. All right. So this is the advantage of fuels. This is very, very important question for exam. What is the advantage of using fuel cells? See, in all this reaction that you have, this electrochemical cell you have seen, whether it is a primary commercial cell or a secondary commercial cell. In all these cases, the corrosion of the electrode takes place. Theoretically, you are supposed to use secondary cell by charging for long time, but you have already experienced with your mobile. After 2 to 3 years, you find the battery does not work. Why? Because the corrosion process is faster than the reconstruction. And in this process, what happens? The electrolyte in your mobile cell dries out. In your automobile also, you can at best use 4 years. Beyond that, you cannot use. But in case of the fuel cell, you have seen we are using the carbon or graphite electrode. In this process of corrosion, carbon and graphite electrode has no role. Their only duty is to get the electron and transfer it to another one. So there is no process of any corrosion. This you need not have to replace the electrodes. As long as you keep the supply of the hydrogen and oxygen in the ratio of, see here, in the ratio of 2:1, you can use it for infinite time. And theoretically, we are supposed to utilize 100% of the electricity from there. But there is a difference between theory and the practice. So till now, we could achieve 70 to 80% of its energy, which is much, much better than any other electrical source. See, electric source, where from you get it? We get it from hydroelectricity. We get it from gas turbine, or we can get it from the thermal power stations, or you can get it from the normal electrochemical cell that you are using making in the laboratory or industry. So fuel cell is the best possible discovery of electrochemistry to produce electricity at a very minimum cost. Why? Because hydrogen and oxygen, they do not cost so much. And moreover, it is totally harmless because it does not produce any pollution. Does not produce any pollution. Okay. What is the byproduct? Byproduct is water. See, water. So this water can be used, and you will be amazed to know that in 1969, that Apollo 11, which landed on the moon, they have used hydrogen oxygen fuel cell as a source of electricity. And whatever the water was generated with the fuel cell, it was being utilized by the astronaut for drinking. So we are looking for the alternative source of energy. People are trying to harness more and more in the form of fuel cell. But disadvantage of fuel cell is that still we are using in a short range. Larger generation of electricity is yet to be started by the fuel cell. Okay, so I finish it today. Then I think I may have to require two more classes